Hello everyone, good afternoon and welcome to another edition of EasyMathsTutor. So today we're going to be solving some sweet and interesting problems that have to do with fractions. Okay, so the last time I explained and taught us about some problems in fractions. So today I'm going to solve actual examples on fractions. So let's go right in and look for some questions. Okay, so we have this exercise that says separate these numbers into proper, improper, and mixed fractions. So we have 11 over 7. We have 5 over 12. We have 2 whole numbers, 7 over 8. We also have 12, and we have 999 over 1000. So we are going to separate these numbers into proper, improper, and mixed fractions. So first of all, we see proper fractions, right? So we have 5 over 12, and we have 999 over 1000. So proper fractions are fractions where you have the numerator, a whole number less than the whole number in the denominator. So that's a proper fraction. Then we have improper fractions. From this list are improper fractions. They are 11 over 7 because the numerator is greater than the denominator. So we have an improper fraction, and then we have mixed fraction. So which of these are the mixed fraction? I guess it will be 2, 7 all over 8. It's mixed because it has a whole number and it also has proper fraction mixed together. So this is the solution to the first exercise. Now, our exercise 2 says, write these fractions as improper fractions. We have the first one whole number 2 over 9. The second one, 2.5. The third one, 3 whole number 3 over 8. The fourth one, 3 whole number 3 over 5. And the fifth one, 6 whole number 10 over 11. Write these fractions as improper fractions. So we're converting these mixed fractions to improper fractions. So I'm just going to quickly show you how we're going to do that. So how do we do that? We say the whole number times the denominator plus 2 all over the denominator. So that gives us 9 plus 2, 11 all over 9. The second one, remember the sequence, the whole number times the denominator plus the numerator. Okay, so that gives us 5 over 2. The next one, the whole number times the denominator plus the numerator all over the denominator. 3 times 8 is 24, plus 3 gives us what? 27 over 8. The next one is the whole number 3 times the denominator 5 plus 3 all over 5. 3 times 5 gives us 15, plus 3 gives us 18 over 5. Now the next we have is the whole number 6 times the denominator plus the numerator, which is 10, all over the denominator. So we have 66 plus 10 giving us 76 all over 11. So finally, let's go over the process of converting a mixed fraction, okay? A mixed fraction. So let's assume this is the whole number. We use W. Then we have the numerator all over the denominator. So the formula for converting a mixed fraction to an improper fraction, okay, is the whole number times the denominator plus the numerator all over the denominator. So as simple as that. Thank you. So our exercise 2 has more examples. So we have F 15, 4 over 15. G is 107 over 10. H is 3 and 4/5. I is 6 and 5/7. Okay, so remember we are converting the mixed fractions to improper fractions. So we'll use the formula I devised. Remember the formula, which is a whole number times the denominator plus the numerator all over the denominator. So let's go right into that. We'll have 15 times 15 plus 4 all over 15. 15 times 15 gives us what? I know that's 225 plus 4 all over 15. So that gives us 229 over 15. So that's a mix. That's an improper fraction. Okay. The next one is 100 times 10 plus 7 all over 10. 100 times 10 gives us 1000 plus 7 all over 10. So we have 1007 over 10. So the next mixed fraction is written in word format. So that will be 3 whole number 4 over 5. 3 and 4/5. That's 3 whole number 4 over 5. So if we're converting it to be 3 times 5 plus 4 all over 5. So that gives us 3 times 5 is 15 plus 4, right? 15 plus 4 over 5. So our final answer will be 19 over 5. So we also have the I exercise 2I, 6 and 5/7. So that is 6, 5/7. Okay? So we convert it, we have 6 times 7 plus 5 all over 7. 6 times 7 is 42 plus 5 over 7. So that gives us 43 over 7. So that's our exercise 2. The second question and all that. So we have our second question saying write these fractions as mixed fractions. That means we're going to convert this improper fraction to a mixed fraction. So I'll clean this board quickly. So now our second question, we'll write these fractions as mixed fractions. So I'll quickly write down all the numbers. So what we have is A. Start from here. That's A. A is 15 over 11. 15 over 11. B is 14 over 3. C is 4 over 3. D is 13 over 7. And E is 21 over 5. Okay. F is 501 over 7. G is 1000 over 33. H is some word problem. So we'll go over to that later. Let's quickly convert these fractions as mixed fractions. All these fractions are already in improper format. They're already in an improper format, improper fraction format. So we're going to convert it to mixed fraction format. So we do it like this. The format is the numerator, which is a greater number, divided by the numerator. Okay? The numerator divided by the denominator, which is 15 divided by 11, which will give us one whole number. Then the remainder, which is 15 minus 11, is what? 4 over 11. Okay? So it is a whole number you get, the remainder all over the denominator. So we also have, excuse me please, we also have 14 divided by 3. That will give us 4 whole number, remainder 2 over 3. Simple as that. While this 4 over 3 will give us one whole number, 1 remainder 1 over 3. This will give us 13 divided by 7 will give us one whole number, remainder 6 over 7. 21 over 5 will give us 4 whole number, remainder 1 over 5. As simple as that, okay? And then 501 over 7. How many times will 7 go into 50? 7 will go into 50 7 times. That is 49. 49 remainder 1, giving us 11. 11 over 7 will give us what? 1 remainder 4. So we have 71 whole number. Okay? If you divide 501 over 7 by 7, you have 71. So our remainder will be 4 over 7. Then we have 333, 1000 over 333. 333 enters 1000 3 times. Remember what? 1. So we will have 30. We will have 30, okay? 30 remainder 10 over 33. 30 remainder 10 over 33. So our H problem says 17 6. 17 6. Okay? 17 6. So that to me looks like 17 times 1 over 6, giving us 17 over 6. Okay? So if we divide 17 by 6, we're going to have 2 whole numbers. 5, remainder 5 over 6. Are we clear about that? Then we have I. I is 59th. 59th. So that tells me or looks to me like 50 times 1 over 9, right? Giving us 50 over 9. 50 divided by 9, what would we have? We know 45 is a multiple of 9, so that will be 5 whole number, remainder 5 over 9. Okay, and then the final exercise in this section is 27 eighths. 27 eighths, which is 27 times 1 over 8. So the final answer will be 27 over 8 as a mixed fraction. Converting it as an improper fraction. Converting it to a mixed fraction, we will have, what is the multiple of 8 that is closest to 27? I think it's 24. Okay, so that will be 3 whole number. 27 minus 24 gives us remainder 3 all over 8. So this is a rundown of this exercise of converting improper fractions to mixed fractions. So write down these fractions as decimals. Write down these fractions as decimals. The first one is 7 over 100. The second fraction is 18 over 100. The third fraction is 51 over 1000. 51 over 1000. And the fourth one is 15 over 10. So let's freshen this, make it clearer, so that you can see. 18 over 1000, 7 over 100. Okay, so we're converting these fractions to decimal places. So it's actually easier for us because the denominator is already in multiples of 10. So it makes it much easier for us to convert. So what do we do? It's simple, okay? First of all, let me write this here clearer. This will be 7 over 100. So to convert it to a decimal, the target is to make the denominator 1. Okay, so how do we make this denominator 1? Remember, these decimal places are all here. This is a decimal, right? So now, to make this 1, we need to move this decimal to be in front of 1. So if we move it to be in front of 1, it will be like this. 1, 2. Can you see that? So whatever you do in the denominator, you have to do in the numerator. So we moved it 2 times to our left. So we're also going to move this 2 times to our left. Okay? We'll fill it up with a 0. So the final answer will be 0.07. 0.07. So now, this is 18 over 100. The same way we did in the first part. Remember, the decimals are located at this point, and the target is to turn the denominator to 1. So this decimal will move it twice to make 100 become 1. Or whatever we do in the denominator, we have to do in the numerator. So we moved it twice, so we'll also move it twice here. 1, 2. Okay? I hope you're getting this. So we'll say 0.18. So that's our solution. The same vein, 51 over 100. The decimals are here naturally, so we'll move it twice. So we have 0.51. Same here, 15 over 10. Okay? The decimals are already naturally at this position. We need to make this one, we'll move it once. To make this one, we'll move this decimal once, and we have to do the same thing here. Okay? For equality's sake, we have to do the same thing we do at the denominator on the numerator and vice versa. So the answer will be 1.5. I hope we got that. If you have any further questions, make your comment in the comment section. Okay, so that's it. So we're going to move to convert these proper fractions to decimal fractions. Okay, so we have A 3 over 5. We have B 3 over 4. We have C, or I think I should write it horizontally. We have A 3 over 5. We have B, okay, 3 over 4. We have C 16 over 25. We have D 1 whole number 1 over 5, and we have E. We have E. Okay, that place will not be very good. So okay, let's just do this ones first. So the question says convert these proper fractions or mixed fractions, whatever they look like, convert them to decimal fractions. So we start with 3 over 5. So I like to use, there are different methods to do this. You could use the long division method. You could also use the decimal method. Okay, so I will say, using the long division method, I will say 5 and what? 30. Okay, so if I put 0 here, then I put a decimal here, I put a decimal here, and here becomes 0. Okay, 30 divided by 5 will give us 6. 6 times 5 will give us 30. So our answer will be 0.6. That's one method. First method. Second method, I will say 3/5. I will also move the decimals accordingly. So I will say this will go here, this will go here. Okay. Let me rephrase that question. So I can say 3/5. In my mind, I assume this is 30, okay? This is 30. So 30 divided by 5 will give us what? 6. And because I added a 0, I'm going to move this decimal backwards, giving us 0.6. That's one method, the second method, okay? So this other style, let's use, for the second question, let's use a long division, which is 4 and 3. So we'll put a decimal, giving us 30. So 30 divided by 4 is what? 7. 7 times 4 is 28. So we have a remainder of 2. Another 0 will enter here. So we have 20 divided by 4 will give us 5. 5 times 4 will give us what? 20. So this decimal is 0.75. So let's try out our second method. Second method, I have 3/4. So I put an imaginary 0 in front. So I will divide 4 by 30. So dividing 4 by 30 will give me 7, right? So we'll have a remainder of 2. 20 divided by 4 will give me 5, okay? So because I put a 0 here and another 0 here, I will move these 2 decimal places, giving me 0.75. Okay, so that is my second method. Now we have another one, 16/25. So we'll put 25 here and 16 here. So the decimal goes in, another 0 goes in. So 160 divided by 25 should give us about 6, right? With some remainders. So we'll have 6 here. So we'll say 6 times 5 will give us 30, remainder 3. 6 times 2 will give us 12. 12 plus 30 is 15, right? So 6 times 25 is 150. 160 minus 150 gives us 10. Remember, another 0 comes here immediately. So we have 100 divided by 25, giving us 4. 4 times 25 gives us our 100. So our answer is 0.6 for this proper fraction. So let's try my second method. My second method goes like this. We'll say 16/25. There'll be an imaginary 0 there, right? So 25 divided by 160 will give us what? 6. Will give us 6. Will give us 6. Remainder 10. Okay. Another imaginary 0 gives us 100. 100 divided by 25 gives us 4. So because we had 2 imaginary zeros, we count 2 decimal places, giving us 0.64. So which of these 2 methods is easier for you or faster for you? If you have to do your examinations, which of them will be faster to do? For me, I prefer the second method. So whichever method is better for you and faster, just adopt that method. Exercise 7. We are going to convert we are going to convert the following fractions to percentages, okay? So the first is 40 over 100. The second is 19 over 100. The third one is 17 over 50. And the fourth one is 1 over 50. So let's do this 4 first, and when we're done, we'll move on and do the next ones, okay? So converting a fraction to a percentage, okay? A fraction to a percentage. If you look at this, it already looks like a percentage. So we'll take it as 40% because the denominator is already 100. A percentage is a fraction whose denominator is already in 100. This also will have the same here, so we have 19%. Now, this fraction, when you look at it, the denominator is 50. So how do we convert this to a percentage? We will simply say 17 over 50 times 100% times 100%. So we'll do this. 50 will go here into 51 places. 50 goes into 100 2 places. 17 times 2 gives us 34%. Okay? Same here, we'll have 1 over 50 times 100%. 50 goes into 51 place. 50 goes into 100 2 places. So our answer will be 2%. 1 times 2 gives us what? 2%. So our E problem, let's take on our E problem. Our E problem will have 8 over 25, sorry. 8 over 25. Converting this to percentage, what do we have? We have 8 over 25 times 100%. 25 will go into 25 1 times. 25 will go into 100 4 times. So 8 times 4% gives us 32%. So our F problem, it will be 13 over 20. So we'll simply multiply this by 100% by 100%. 20 goes into 21 times. 20 goes into 100 5 times. So 13 times 5 gives us 65%. Then we have the G problem, which is 50 over 25. 50 over 25. This is an improper fraction. Okay? So how do we convert it? We'll multiply by 100%. 25 goes here 1, 25 goes here 4 times. So 50 times 4% gives us what? 200%. Okay? Then we have H. The H part is 57 over 50 times 100%. 50 goes into 50 1 time. 50 goes into 100 2 times. 2 times 7 gives us what? 14, remember 1. 2 times 5 gives us 10 plus 1, 11. 114%. Then we have a mixed fraction. Let me use, okay, first of all, let's solve this one before we go to the mixed fraction. We have 11 over 20, converting to percent. We have 20 goes here 1, 20 goes here 5, giving us what? 55%. IJ. Okay? J is 1 whole number 1 over 4. Okay? So, how I do mine, I don't bother to I don't bother to convert to mixed fraction. There are going to be a couple of methods. Two methods we'll use for this. So my first method is, I'll take 1 as 100% already, right? 100% already, plus 1 over 4. 1 over 4 times 100%. 1 over 4 times 100%. So what do we have? 4 goes here 1, 4 goes here 25. So we have 100% plus 25%. That gives us 125%. The second method will convert the mixed fraction to an improper fraction, okay? So remember, it's a whole number times the denominator plus the numerator all over the denominator. So, which is 1 times 4 gives us 4 plus 1, giving us 5 over 4. Converting this to percentage, 4 goes into 4 one time, 4 goes into 125 times. So 25 times 5 gives us 125%. Okay? So whichever method is easier for you, you follow it and know how you're going to be faster during your examinations. And this exercise involves converting decimal numbers to percentages, okay? So we have our first question, 0.25. Our second is 0.831. I actually love converting decimals to percentages because it's the easiest question you can ever make in mathematics. So just watch how I'm going to crack it and make it very simple. Convert 0.17. Remember, when you're mentioning the decimals, you do not call them as whole numbers. You cannot say 0.25. Rather, you say 0.25. You cannot say 0.831. That's tautology, okay, in mathematics. You say 0.831. You cannot say 0.17. You say 0.17. Then D is what? 0.04. 0.04. Then we have E. E is 0.875. Okay, so we're converting these to percentages. We're converting these to percentages. So we say 0.25 times 100%. So you have 2 zeros. So we're going to count this decimal backwards. Okay, to knock off these 2 zeros, we'll count this decimal backwards. So we have 2 zeros, 1, 2, 1, 2, giving us 25%. Giving us 25%. Or, this is the first method. Now, second method, I will say 0.25 is equal to 25 all over 100. You see? The decimal takes 1, and the 2 decimal places takes what? 2 zeros. So it's already a percentage. Remember, a percentage is a fraction whose denominator is 100. So for the B part, the first method will say 0.831 times 100%. So we're going to knock off these 2 zeros by counting 2 decimal places. Decimal place to your right, 2 decimal places to your right, and it ends behind 3. So we have 83.1%. The second method will say 0.831 is also 831 over 1000. Why? Because, why is it like that? Because this decimal represents 1, and these 3 decimal places represent 3 zeros. Okay, so let's move on with our second method. So we'll say 831 over 1000 times 100%. 2, 2, right? 2, 2, giving us what? Giving us 83.1%. Okay, 83.1%. Or let me rephrase this make it clearer. Let's try something else. We'll say 0.831 all over equal to 83.1 over 100. Okay, which is also 83.1%. So now let's move on to the next exercise. So this is what you can see now. 0.17 is the same thing as 17 over 100, which is also 17%. Okay, that's for C. Then D, 0.04 is the same thing as 4 over 100, which is the same thing as 4%. Okay, 0.875, 0.875 is the same thing as 87.5 over 100, which is also 87.5%, which is also 87.5%. Okay, so we have another question in our exercise 7, which says, express these percentages as fractions, simplifying each answer to its lowest terms. Okay, so the first one is A, 10%, B, 16%, C, 0.75%, D, 1 over 9%, E, 190%. So the question says, express these percentages as fractions, simplifying each answer to its lowest term. Simplifying each answer to its lowest term. So we know that 10% is equal to 10 over 100. So how do we reduce it? The lowest term. The lowest term is 1 over 10. Okay? Now the next question is 16%. We know 16% is 16 over 100. The lowest term, we know that 4 goes into 16 4 times, 4 goes into 100 25 times. So our lowest term fraction is 4 over 25. The next is 0.75%, which is equal to 0.75 over 100. Okay, now you cannot have a proper fraction having a decimal and a whole number. We'll have to convert this decimal to a whole number. How do we do that? We move this decimal 2 times to the right. And remember, whatever you do at the numerator has to be symmetrical with the denominator. So the denominator decimal is after 100. We'll also move 2 decimal places. So add 0 here. So we'll have 75 all over 10,000. 75 over 10,000. So first of all, let's try dividing through by 25 or dividing through by 5. 5 goes here 1, 5 goes here 5, that is 15. 5 goes here 2, that is 2000. So we'll try another 5, okay? So we'll say 5 goes here, let's bring this down, 15 over 2000. 5 goes into 15 3 times. 5 goes into 20,000 24 times 0, 0, 400 times. So our fraction is 3 over 400. And then we have 11 and 1 over 9. So I would like us to convert this to an improper fraction first of all before we start to work. So we have 11 times 9, which is what? 99 plus 1, giving us 100 over 9 times 100 over 9 all over 100. 100 over 9 all over 100. Remember what I just did. I didn't do magic here. What I just did was this divided by 100. Okay? And then if we convert this, it will turn to what? 1 over, it turns to 1 over 100. This and this are the same thing. Okay? A number multiplied gives us the inverse of the number divided. So this will cancel this, giving us what? 1 over 9. 1 over 9, that's the lowest term. Then we have 190% is the same thing as 190 over 100. So how do we reduce it to the lowest? First of all, cancel out the 0, giving us 19 over 10. We can also convert this to a mixed fraction, which is 10 divided by 19 divided by 10 gives us one whole number, remainder 9 over 10. There's also another problem we're going to solve here, which says write these percentages as decimal numbers. Write these percentages as decimal numbers. Okay, I think that was what we did at the beginning. Okay. A is 80%, B is, let's say, 19%, C is, let's say, 0.5%, D is 64%. Okay, so convert these to decimals. 80% is the same thing as 100, 80 over 100. So we're moving our decimal to make sure that the denominator is at 1. Okay, 1, 2. 2 decimal places to the left gives us 1 in the denominator. So we'll do the same thing at the numerator, which will give us 0.8. That's for A. We have 19 over 100. We'll move this decimal 2 places to give us 1 at the denominator. Or whatever we do at the denominator, we have to do at the numerator, giving us 0.19. Okay? So we'll put a 0 here to make it complete. That's for that. Then we have 0.5 over 100. Okay? So what do we do to make this 1? We'll move this decimal 2 places. Then whatever we do at the denominator must be done at the numerator. 1, 2. So we have 0.005. Then we'll put a 0 here to make it look complete. Then we have 64 over 100. So we'll move these 2 decimal places, giving us 1 in the denominator, and we must do the same thing in the numerator, giving us 0.64. I'll put 0 in front, and then we get this. Welcome back. I have a diagram that has 100 boxes. This diagram has 100 boxes. So if we look at the diagram, this diagram represents a whole percentage because it contains 100 boxes. So assuming we have 2%, this is how we represent 2% in this diagram. 2% is 2 boxes out of 100 boxes. So if we want to say 50% of this box, that means we'll count 50 boxes out of this whole problem. Okay, so let's count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 50 boxes out of 100, which will give us what? 50%. Okay, the remaining will also be 50, which will give us also 50%. So the whole box will give us what? 100%. And we know that 50% is half, okay? Why? Because 50 over 100 will give us 1 over 2. So 50% of a whole means half of the whole population.